soaps and detergents. Okay. Right. And what are soaps? Soaps are sodium and potassium. Sodium are, we wrote that, are potassium salts of long chain, okay, long chain carboxylic acid, long chain carboxylic acid. Okay, so what will be the general formula here? R COONA plus. R can be H or any other reactants also can be there. It will be a long chain will be there. Okay. Then structure of the soap. This also we wrote. Okay. We have to write the explanation, I think. No? Okay. So structure of a soap molecule. Soap molecule.
What is G?
General formula. Write down soap molecule. Write down this. They will ask about the structure of soap molecule or some related question to this. Okay. Soap molecule have different properties. They have different properties at two ends. That means even in a just one molecule, we will have two different properties. Just open the door. Two different properties. Okay. In just one molecule, it has two different properties. That is hydrophobic in nature and hydrophilic in nature. Okay. Hydrophobic meaning it will not dissolve in the water. Hydrophilic in nature, that means it dissolves in the water, because we know sodium will dissolve in the water, whereas long carbon chains, they don't dissolve in the water, that because they are covalent bonds. We learned that. Do you remember? Covalent bonds will not dissolve in the water, but they dissolve in organic compounds. They dissolve in the organic solvents. We learned that. So, hydrophobic and hydrophilic. Hydrophobic means it dissolves in the water. It does not dissolve in the water. Hydrophilic means it dissolves in the water. We'll write that. Okay, so same like you will have two different properties in the same molecule. Because of that, they will form the molecules orient themselves in the form of micelles. Okay, which will attract the dirt and oil present in the clothes. Okay, then other than that, when you rinse that with the water, what happens? It can be easily removed out. What is the reason? Because all negative ions are oriented one side, positive ions are oriented one side. So what happens? Since there are negative ions repel each other, they don't stick to anything. When you just rinse that, dirt and the micelles can be removed easily. Okay, so that's how it can be used for the washing purpose. Okay, write down. We'll write. Okay. Yeah.
The properties in the testing in the program, since the electrons share reaction, there is no charge particles at all.
Where? In the car. You are studying something else. Because you have not come so many classes, you have a lot of notes. You cannot clarify like this. Okay, after the class you ask, you will explain. Otherwise, everyone else will get confused. Okay. Okay, listen here. If anyone having doubt, listen once again. Okay. See, first thing is soap molecule. What does it contain? It contains sodium or potassium salts of long chain carboxylic acid. That means here we have written the sodium here. Okay, this is sodium. And we have long chain. You can write R or H, COO minus. Okay, what is carboxylic acid? It will be, or if I write, wait, what? Ethanoic acid is this, correct? Ethanoic acid is this. Sodium acetate, if I write, this is the formula, correct? This part is long chain carboxylic acid, correct? And this is the ion, sodium ion. Okay, so the soap molecule will be like this. But many times, instead of CH3COO, it may be the very long chain, it can be there. That is maybe 6. Here they've given C15H31. Maybe the still very long chain. So many times they write it as, RCOONA, because this R is still bigger chain. COO will indicate it is carboxylic chain. Okay, so one H is replaced by sodium. Now, what happens? This is minus part. This will be minus Na plus. So Na plus, it's an ion. Okay, sodium will dissolve in the water. Sodium ion will dissolve in the water, whereas this carboxylic chain will be there. No, that will not dissolve in the water. Okay. Usually, the covalent compounds will not dissolve in the water, whereas the ion, sodium ion or a potassium ion, will dissolve in the water. Okay, so the molecule contains both the carboxylic acid chain as well as the ion. Okay, so this part will dissolve in the water, whereas this portion will not dissolve in the water. So what happens? How it will be there? It will be in this. It will be like this. We'll write like this. It will form the, each molecule will orient itself like this. Each molecule will orient itself like this. Okay. This portion is in the water because Na plus. Okay. This portion is above the water. Okay. One molecule. This itself is just one molecule. In that, one portion sodium will be inside the water, whereas carboxylic chain will be outside the water. So each molecule will orient itself like this. Many molecules together, they form the micelles. Now understood? Understood? No, this one is one molecule. Let me complete. You ask your doubt. Okay. So this is a molecule. Okay. So each molecule, it is like this, where this is Na portion, it is inside the water, whereas carboxylic chain, which is in the same molecule, will be outside the water. So each molecule, it will be like this orientation. So many molecules together, it forms the micelles. Okay, and these micelles will attract the oil or dirt present in the clothes. Okay, so that will be attracted at the center. Since ions are formed, here it is minus, here it is plus. Correct, no? So they will attract oil or dirt present in that clothes. Okay, so that will be attracted at the center. Now, once you rinse that, okay, once you rinse that in a clothes in clean water, what happens? Those micelles will be rinsed out, will be removed out easily. They will not stick to the clothes. What is the reason? Because here all negative ions are formed like this, correct? Negative ions come in one portion like this, where negative ions, what happens? These negative ions repel each other, correct? That is the reason once you rinse the clothes, whatever the micelles present on that will be rinsed or removed with the water. So easily you can remove that out. See, if micelles only will stick to the clothes, what happens? Removing that only, still again it's difficult, right? So that should be rinsed out easily. So that's how it is rinsed. Now understood why this micelle formation will be there and why you can rinse that micelle easily, remove that micelles also easily from the clothes, means because of the molecule, because one side it has a character of hydrophilic, other side hydrophobic. Hydrophobic means it is not with the water, right? Phobic means. So what does it mean? It will not dissolve with the water. Hydrophilic, it will dissolve in the water. Since the same molecule has the two different properties, they have the orientation like this, and they can be easily removed from the clothes. Now understood? Now you have doubt?
So the entirety of the same molecule is found by a covalent bond.
Covalent, not only covalent bond only.
Ions are also
It's not only covalent. That carboxylic acid was covalent bond. With the sodium, it forms ionic bond. It's too complex thing actually. Both are there. See, this CH3COOH, it is purely a covalent bond. Now, that reacts with the sodium. Then only you will get this now. NaOH or sodium, you will get sodium acetate. Like this, correct? This was the equation. So, here it is an ionic bond. This is minus part, this is plus part. 1 minus 1 plus, it would be ionic. So, it is a complex thing. This portion, it has covalent bond, whereas the all together it's ionic, like that. Understood? No? Understood?
not just considered a covalent bond.
Both it is there. As you go on, no, everything will be there. It's not so easy. Like very simple things you can tell, like that purely covalent bond, purely ionic bond. Now, both is there. What you will tell. Okay. CH3CO will become one ion. Na plus will be one ion. They get attracted. So what you call that? CH3COO within that, whatever is there, that is because of covalent bond. Then, like that.
More of an upstream bond than a covalent bond.
Whatever you can think.
On a broader spectrum,
Ah.
more is an ionic bond.
Understood? No. So this much understood? Clear? Still inside the compound, how it will be there, like more than that, you should read next part chemistry. Okay. Now in this portion, this much only is clear? Yes. Okay. Write down. It has one end, or its one end. I will write it. 1 second. Wait. Its one end is hydrophilic, that is soluble in water. Soluble in water. And the other is hydrophobic in nature. Hydrophobic, that is soluble in fats. Soluble in fats or oils. Okay. At the surface of water, the hydrophobic end or tail of soap will be insoluble in water. And the soap will align along the surface of water with the ionic end in water, and the hydrocarbon tail out of the water. Out of the water. That means the tail part will be out of the water. This when it is formed like this, right? So this
What is it? Air or something?
above the water, that's on the water. One is inside means where it can be there, just above the water it will be there. Okay.
So is that why it's so close?
Ah, that's how it will be there.
Never mind.
Okay. They form or molecules form form micelles. That is cluster of molecules. Cluster of molecules. Okay. Or the form. That is the formation of, right, the formation of cluster of molecules is called micelles. It is called micelles. So how they together combine like clusters, right? Like this. How they are oriented. Each molecule is oriented together. Okay. So that they call it as micelles. Okay. So this is Na. What is that? Na plus. Pavan, now you will be talking nicely afterwards. Whatever I ask, I don't know, ma'am, you will tell. Huh? Huh. And this will be carbon chain here. That is carboxylic chain. Okay. And why the dirt or oil will be attracted in the center of the micelles means because they are negative ions, no? They attract the dirt or oil. Okay. And they don't stick to that. Micelles will not stick to anything because they repel each other. No, already negative ions. Usually we don't get like negative ions gets oriented one side. Because of this special property of hydrophilic and hydrophobic, all the negative ions will be oriented in the same direction. Now they repel each other. So once you rinse the clothes, it will be repelled. Since they repel each other, they will not stick to anything. They will be removed easily. Okay. So in two things here is one, they can attract the dirt or the oil content, and the second one is it can be removed easily. What is the reason? Because of hydrophilic and hydrophobic, both the characteristics, it is present in the same molecule. Okay. So what is that chain contains? It contains either potassium or sodium long chain of carboxylic acid. That is, it has the carboxylic acid chain as well as a sodium or a potassium ion. Okay. So one H will be replaced by either sodium or a potassium because both have the same valence. Here you will write it as R because usually it will be a long chain like C15, C16, what else written the same way. Whole molecule will contain long chain of carboxylic acid. That's why they're just written as R. Okay. Clear now? This also they will ask and write micelle formation. Then you write that tail part, head part, what is that? All this you should write. Then you should explain that. Then everyone written this much. So that the formation or the orientation of cluster of molecules, that they call it as micelles. That orientation or formation of that molecules together, how that cluster will be there, they call it as the micelles. Okay, that will attract oil or dirt at the center of the micelles. Okay, write down in the form of micelle, in the form of micelle, Soap is able to clean since the oil or dirt is being collected is being collected in the center of the micelle, in the center of micelles. One second. Huh. In the center of the micelle. Right now, micelles stay as collide, stay as collides stay as collides in the solution and does not come together to precipitate due to ion-ion repulsion. Ion-ion repulsion. Hence, the dirt suspended in the micelles is also easily rinsed away. It is also easily rinsed away. Listen now, detergents. See, what is the difference between a soap and a detergent? Soaps work well in the soft water. They don't work well with the hard water. Okay. What does the hard water contains? Calcium or magnesium salts. See, water, if it contains calcium or magnesium salts, then it becomes the hard water. Okay. Soap works well with the soft water, but it does not works well with the hard water. What is the reason? The soap reacts with calcium and potassium. The soap reacts with calcium and potassium. Okay. When they react with calcium and potassium, they form the precipitate. They don't form the foam or the lather. Okay. They don't form foam or lather. Okay. That is the reason they don't work well with the hard water. So detergents are used with the hot water. Why it is used with the hot water? It contains the either ammonium salts of chlorine or bromine. Okay, detergents contains ammonium salts, okay, of calcium or of chlorine or bromine. They contains calcium or bromine, okay, or it will contain sodium salts of sulfonic acid. So what happens there? They do not react, detergents, they do not react with calcium or magnesium salts, and hence they form the lacquer. Okay.
How does sodium salt get into water? How does sodium salt go off the water?
You put in the soap, it will there no sodium salts.
No, the one that detergent is okay, it's kind of a hard one that it's pretty wet. Sodium salt.
You put in the soap, soap will contain sodium. That reacts with calcium or magnesium salts.
Soft water is hard water.
Soft water, see, contains hard water contains calcium salts. or magnesium salts from, see, in the water, where from where you will take, either you will take from the underground water or the river water, correct? No, underground water in many places it contains calcium and magnesium salts. It is in the earth. Why this is there, that's all. Minerals are present in earth only, no? In some places it is there. So there the underground water contains the calcium and magnesium salt, so it is called hard water. Okay, it will be present in the nature. That's all. Okay. So calcium salts are magnesium salts. Calcium salts are magnesium salts. Okay. So if the water contains calcium or magnesium salts, if the water contains calcium or magnesium salts, then it is called as a hard water. So soaps do not work well with the hard water. What is the reason? Soaps contains the sodium salts, that is carboxylic chain of sodium salts. They react with calcium and magnesium salts. They form a precipitate. So they don't form lather more. Forms the lather not much. So because of that, what happens? Soap, when you need to put more soap on it, that is space more. Okay, that is the one reason. So what they will do? They will use detergents. They will use the detergents. So detergents, okay, either they will have the ammonium salts. Okay, they will have the ammonium salts which do not react with calcium or magnesium salts. So then what happens? They form more lather or foam, what you call, that will be more, hence that can be used. But soaps and detergents, if you consider, soaps are better when compared to detergents. Because even the, because when you wash that, clothes quality will be better with the soaps when compared to detergents, and also the it will not pollute more when you compare with the it will not pollute more when compared to detergents. So when compared to detergents, actually soaps are better. Okay. So they are better. One thing. Okay, but it will not work with the hard water. It works with the soap. Write down this. Detergents are generally sodium salts, sodium salts of of sulfonic acids or ammonium salts, ammonium salts with chlorine, or bromide ions, and both have long hydrocarbon chains. Hydrocarbon chains. Hydrocarbon chain. Okay, both have long hydrocarbon chains. So this test after Deepavali, maybe Saturday, I think I have given in the this also group also have put. Or this Saturday, next Saturday. Okay. Here we will end the today's class. Do not forget to subscribe the channel. If the content of this channel is useful, please like the video and share with your friends. Thank you.